So I mentioned this in the last video, this line of best fit. All right, it's because the data will very rarely fit a line exactly. You're always going to have something that's out of place. As you can see below, we have all of our dots, and we have this line that the calculator calculated as the line of best fit. Line of best fit. Oops, not bit, fit. Or it's also called the least squares line. That's because linear regression can also be thought of as a least squares regression. Least squares line. All right, and our calculator is going to decide the line that best fits the data. And we'll also have coefficients that help us determine how well it fits the data, or how bad, how not great, I should say, it fits the data. All right, so we are looking here in this example at 11 statistics students who had a third exam score out of 80 and a final exam score out of 200. So we're going to see that maybe if someone did well on the third exam, that they would do well on the final. Okay, see if maybe that is a relationship with each other. So these are all paired data. That's one student who had their third and their final exam, 65 on the third exam, 175 on the final. All right, we are going to go to our online calculator to predict the line of best fit, so that we could maybe predict the exam score of a student if you knew what their third exam score was. Okay, this is regression analysis. We are using our same normal calculators. So I went back to my LibreText statistics calculators. The very bottom, we have this regression analysis. That's where we're going to go. And you have a couple options here. You can put the ordered pairs in one at a time, but then you have to do every single one at a time. Or you can put in all the data separated by commas, but again, be very careful that you are putting them in paired up, like the first pieces go together. So I'm going to go and put all my X's in, but I'm going to be very careful that I put them in the correct order. So 65, 67, 71. I encourage you to do this along with me, okay? Don't just watch me do it, but practice doing it yourself. 66, 75, 67, 70, 71, 69, and 69. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, I at least have the 11 pieces. Hopefully they are right. 175, 133, 185, 163, 126, 198, 153, 163, 159, 151, and 159. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, hopefully those are right. When you click plot points, now that they're all typed in, I'm going to click plot points up here, and you'll see that the picture shows what I screenshotted and put in our notes already. All right, we have down here, as soon as I type that in, we have our regression equation, we have our R value, and we have an R squared value. All right. The R value is our correlation coefficient. The regression equation is that equation I referred to earlier, y equals a plus bx. All right, so we're going to copy both of these down. I'm going to go over to my notes and type or write them in. Oops. The regression equation was y equals negative 173.5134. You'll see that the calculator says y hat. It's because this is an estimation. This is a line of best fit. It's not entirely accurate, but if you just write it as a y instead of a y hat, that's totally okay. Don't worry too much about that. All right, that was our regression equation. Our correlation coefficient rounded to 4 decimal places was 0.6631. Now, the regression equation is important. It's because this is actually letting you know how good your line is fit. If your R is 1 or -1, your line is perfect. It touches every single piece of data. If your R is 0, that means that there really is no correlation going on. And here we have 0.6. It's closer to 1 than it is to 0, but you can see that this line is not the best when it comes to all of our data. Right? Our data just isn't, it's correlated, but it's not that strong. It's pretty spread out when it comes to where our line of best fit went. Right? And you can see that in the R value as well. Positive correlation because the R value is positive, but it's pretty far away from 1. So it's not that good of a fit. With that, we can still estimate, we can still use it to calculate a value. So that's what we're going to do here. It says, suppose a student got a 72 on the third exam. X is third exam. Y is final exam. In this equation that the calculator just created for us, the X is the third exam score. The Y is the final exam score. That is the same as the data that you collect and put in. Your equation creates an equation, your calculator creates an equation that has that same input variable and that same output variable. So here it says a student got a 72 on the third exam. That means that X is 72. Predict their final exam score. We want to know what is Y if X is 72. So I take my equation and I just plug in 72 for X. I cannot talk. Whew. I need to do one thing at a time. 173.5134 negative 173.5134 plus 4.8274 times X multiplied by 72. That's the X that I am putting into my equation. All right, multiplication goes first. So you would multiply these two first. And then you would subtract 173.5134 from that value. When you put that all into your calculator together, you should be practicing putting this into your calculator together. You should get 174.0594. They would get about a 174.1. We'll just do one decimal place on their final exam. That would be our estimation for their final exam based on what they got on their midterm, on their exam 3. All right, and that's one example of us not just finding a line of best fit, but using it to predict a value. Right? We didn't know a student that actually got a 72. So we're using this line of best fit to predict that if they got a 72, what they might get on their final according to the rest of our data and this line of best fit that we have created.